Have you ever pondered about the mysterious relationship between light and gravity? Welcome to the Enigma that has intrigued scientists for centuries. We're embarking on a journey to explore the paradoxical nature of light and gravity. You see, light, which is composed of photons, is widely accepted as having no mass. Yet it behaves in a way that defies this understanding. When light passes near a massive object, it bends. It's as if it's pulled by an unseen force, a force we know as gravity. This is where the concept of space-time curvature comes into play. Imagine space-time as a fabric, a sort of cosmic trampoline. When a massive object, say a planet or a star, sits on this fabric, it creates a dent, a curvature. This bend in space-time is what affects the path of light, causing it to curve. So how can something with no mass like light be influenced by gravity? The answer lies in the fabric of space and time itself. The key to understanding this paradox lies within Einstein's theory of general relativity. Now let's delve into this theory a bit. In the early 20th century, Albert Einstein proposed a revolutionary idea that completely changed our understanding of the universe. He suggested that gravity isn't a force that pulls objects towards each other, as Sir Isaac Newton had previously theorized. Rather, Einstein described gravity as a curvature in the fabric of space and time, caused by mass. Imagine a bowling ball placed on a trampoline. The weight of the ball causes the trampoline to curve downwards, creating a sort of well. Now, if you roll a marble along the trampoline, it will naturally follow the curve and circle the bowling ball. This is a simple analogy for how gravity works according to the theory of general relativity. So, how does light fit into all this? Well, although light has no mass, it travels through space-time, which can be curved by gravity. Consequently, the path that light takes can be bent or warped by the gravitational field of a massive object. This is known as gravitational lensing. It's as if light is traveling on a winding road shaped by the mass of objects in the universe, rather than a straight highway. Despite being massless, light is obliged to follow the rules of the cosmic highway. It's like an obedient driver sticking to the speed limit, following the twists and turns dictated by the massive objects it encounters along its journey. This is why we see light from distant stars appearing to curve as it passes close to a massive object, like a black hole or a large galaxy. The light isn't actually falling into the gravitational well of these objects. Instead, it's merely following the curvature of space-time that these massive objects create. So, light doesn't really fall into a gravitational well. Instead, it follows the curved space-time around the massive object. But don't just take Einstein's theory for it, we've seen this phenomenon in action. The universe has served up some fascinating real-world evidence of light bending around massive objects. This cosmic magic trick is known as gravitational lensing. It's like a cosmic funhouse mirror, where the gravity of a massive object distorts and magnifies the light from objects behind it, creating a lens effect. Now let's wind the clock back to the year 1919. During a total solar eclipse, Sir Arthur Eddington conducted an experiment. He observed the positions of stars near the eclipsed sun, and guess what? Their apparent positions had shifted. The light from the stars had been bent as it passed the sun. This was a confirmation of Einstein's predictions and a revolutionary moment in science. These observations provide compelling evidence that light, despite having no mass, is indeed affected by gravity. So, what does all of this mean for our understanding of the universe? Let's take a moment to summarize. The enigma of light and gravity is not just a fascinating scientific curiosity, it's a crucial piece of the cosmic puzzle that is our universe. The theory of relativity opened our eyes to a new way of viewing the universe, where space and time are intertwined and where gravity is not just a force but a warping of this space-time fabric. Light, despite having no mass, is affected by this warping, bending its path as it travels through space. This understanding has profound implications, from the swirling light-swallowing abysses of black holes to the future of space travel. It shapes our perception of the universe, challenging us to reconsider what we thought we knew. In the grand cosmic dance, even light, weightless as it is, can't resist the pull of gravity. And that's a beautiful thought to ponder upon.